All right, we're going to take a look at some of the review problems that we have for the exam. The first couple I've got up here, they're asking me to find the vertex, focus, and directrix of each parabola. In order to do that, I need to know two other pieces of information. I need to know which way the parabola is opening, and then I need to know that A value, in other words, what the distance is between the vertex and the focus, or vertex and directrix. So, on number one, the y is squared, and then I've got a negative, so I know this is opening left. So in other words, looks something like that. Vertex, -4, -1, h is with x, k is with y. The A value, or distance between the vertex and focus, or vertex and directrix, would be 4. So where that's coming from is 4A is 16. Now the negative told me which way it opened. I'm looking at that value of 16. So if I solve that for A, that would give me 4. So I'm moving 4 units, and I'm moving 4 units left for my focus. So that would give me my focus at being -8, -1. Directrix would be a vertical line behind the parabola. So it would be x equals, and 4 units to the right, so x equals 0. Now, as far as moving to get that focus and directrix, remember, if easier, I can always plot my vertex. There's my vertex. Now I don't know how wide the parabola is, but I can just get a generic sketch here, something like that. And then I can count 4 places for where that focus is, and I would be at -8, -1, and I can count back 4 places to where that vertical line or directrix would be, and that would be x equals 0. So I can plot the vertex pretty quick and count if I need more of a visual. The second one, this one is opening up. I see the x squared, I see the positive. So in other words, looking something like that. Vertex, -4, -1 again. And h is with x, k is with y. The a value this time is 5. I've got a 20, so if 4a equals 20, that would give me an a value of 5. Focus, I'm going to go 5 units up, which would be at -4, 4. Again, if I'm a person that's in need of a visual, if I like having that visual, I can plot that vertex, -4, -1. Draw that generic parabola, count up 5 units, and then I will be at -4, +4. And then if I count down 5 units, it would be a horizontal line for my directrix. Y equals -6 would be where that horizontal line would be. The next set of questions, 3, 4, and 5, are asking me to find the equation of the parabola, given some information. Now, I'll still stress that I need to know which way it's opening, so I know which generic form I'm using. Am I going to have an x squared, a y squared? Is it going to be up, down, left, or right? Okay, that positive or negative. Okay. So, this is where I think a lot of times a quick plot of what I'm given can help with that direction. So number 3, I'm given a vertex at 2, 8. There's 2, 8 vertex. Right. I'm given a focus at 3, 8. There's 2, 8, and so 3, 8 right next to it. There's my focus, 3, 8. And remember, the focus is inside the parabola, so that's telling me that this thing's opening to the right. So it's looking something like that. So I know it is y minus k squared is positive 4a x minus h. Well, I've got my vertex 2, 8, so y minus 8 squared something x minus 2. I just need that a value. The distance between the vertex and the focus is a, and that is 1 unit, from 2 to 3. So 4 times 1 is 4. There's my equation. 4. Same idea. I'm going to plot. Let's see. 1, 7. There's my vertex. 1, 3 down here. There's my focus. Something like that. And that means that this parabola has to be opening down. So something along those lines. So now I know it's x minus h squared negative 4a y minus k. So again, I have my h and k. X minus 1 squared y minus 7 over there. I need that a value. So right here, from vertex to focus, a would be 4 units going from 7 down to 3. And so 4 times 4 is 16. There's my negative 16 there. Fifth one, vertex at 8, negative 6. Again, to help me, I'm just going to do a quick sketch here. Just kind of give me an orientation. I'm just going to get set of an orientation of which way this thing's got to be going. 8, negative 1 is the focus. So I'll say right here is a focus. And that means this thing's got to be going up. So I'm going to have x squared and the positive. So x minus h squared, positive 4a y minus k. I have my vertex, so x minus 8 squared, y plus 6. And again, I need that a value. The distance from the focus to the vertex in this case would be 5 units. So I'm going from negative 6 to negative 1, so a is 5. Giving me a 20 there, 4 times 5 being 20. 6 and 7, a couple of application problems. Paraboloid of revolution, so it just means a 3-dimensional parabola. We are given that it's 18 inches across at the opening and 2 feet deep. Where will the light be concentrated? Where the light's concentrated is going to be referring back to that focus. So we're really looking for how far that focus is going to be away from that vertex. We're going to be looking for the a value. So I need an equation here. I'm going to a little sketch here. I'm going to put my vertex at 0, 0, and I'm going to open it up. I don't need a most perfect graph. It kind of gives me an idea of what's going on. Okay. Now, in the previous problems, in order for me to get the equation, I had to graph what I was given. So this one, well, I've noticed a graph or plot, quick plot of a couple points can help me. Here, I can put that parabola wherever I want. I'm picking 0, 0 for the vertex, an easier vertex for me. And opening up. I can open it any direction. I'm just a little bit more confident when it's opening up. It's a little more familiar to me. Right. So I've got a vertex here, 0, 0. Some other information I'm given. It's 18 inches across at its opening and 2 feet deep. All right, 18 inches across. So that's going to be 9, comma, negative 9, comma. That would be 18 inches across. 2 feet at its opening. 24, 24. I've got to be careful here. I'm actually given a problem with 2 different units. I can't work in inches and feet. I need to work in inches or I need to work in feet. I'm picking inches, no particular reason. If I would like, so I did 18 inches. There's negative 9 to 9 is 18, so I need to change 2 feet to 24 inches. If I would rather work in feet, well, I'd have a 2 here, and then 18 inches would be 1.5 feet. So I'd have a 0.75 and a negative 0.75 if I would rather be in feet. It's going to work out the same way. I just selected inches because I didn't want the decimal. There's no other reason other than that. Okay. So I know this is going to be x squared equals 4ay. And again, I know h and k are 0 and 0, so I can jump right to that x squared and the y. So kind of back to this guy, I've got a 0 for h, so that's just going to be x squared, 0 for y, or 0 for k, so that's just going to be a y. Right? I have a point. I could use either point because I'm squaring that x. It doesn't matter positive or negative. So 9 squared, 4a times 24. And 9 squared is 81. 4 times 24 is 96a. And so a would be, at distance from vertex to focus, 81 over 96 inches. Of course, if I want a decimal, I can go get a decimal for that. That would also be fine. Fraction's fine. If I have been working in feet, I would get an answer, a decimal amount of feet that would be equivalent to that amount in inches. Right. 7. Given some more information about a parabola, I'm still going to put the vertex at 0, 0. I'm still going to open it up. Again, I'm trying to select something, or an orientation, I should say, that's going to make things a little easier for me. And that vertex at 0, 0 and opening up is a little bit more standard for me, or a little bit more to my liking, so that's why I'm picking that. All right, light source is located 3 feet from the base along the axis of symmetry, and its opening is 10 feet. Now, one nice thing here, I don't have to worry about units. They're all in feet, okay? So if the opening's 10 feet, and it says how deep should it be, so that means this point would be 5 comma something, negative 5 comma something. I don't know that y value. That's what I'm being asked for, is how deep it is. Right? But I was given the information that there is a focus right here 3 feet away. And that 3 is the a value. That was the distance from vertex to focus. So build my equation. Again, I'm going to have x squared is 4ay. Because I know h and k are 0, 0. That's the way I created it. Well, I can solve this for y because I have an x value of 5 or negative 5. I'm squaring, so either one will work. And I have an a value of 3. So 5 squared, 4 times 3 times y. Y would be 25/12 feet. So the depth at those two endpoints would be 25/12 feet, or again, mixed number 2 and 1/12 is fine. Going to a decimal is also fine, but that's going to give me that y value there. Number 8 switches us over to an ellipse. So 8, 9, make sure I'm looking right here, 10, 8, 9, and 10, same instructions. Find the center, foci, vertices. Right? The vertices are referring to the major vertices, my ellipse. What I need to also remember is I need to know the orientation of the ellipse to kind of figure out where that foci and the vertices are. Okay? So for an ellipse, the largest number is giving me the orientation. So on this particular problem, 81 is under the y squared. That's bigger than the 4, so that tells me that this is going to be a vertical ellipse. And if I need a little picture, I can do that. I know it's going to be stretched vertically. My center, 0, 0. I don't see anything plus or minus up there with the x and y. My A value is 9. My B value is 2. So A squared is 81, so A is 9. B squared is 4, so B is 2. And C would be 81 minus 4, which is 77. So root 77 would be my C value, or decimal is fine there. There's nothing wrong with using a decimal there if you'd rather use that than the radical. Okay. Foci and vertices. Okay. Vertices, and again, this is referring to my major vertices it's asking for. They are 9 units away from the center, and they have to be up and down because it was vertical. So I would have 0 plus or minus 9. Again, a picture can sometimes help. There's my center, 0, 0, and I would have to come up here to 9 and down here to -9 to get where those vertices are going to be. Foci are C distance along that major axis. So I would have 0 plus or minus root 77. Or again, I could go through, use a decimal. I could also write those as separate points, like 0, 9, 0, -9. The plus and minus is fine, or separately is fine. 9. Little tougher view, I think, a lot of times when the center is moved away from the origin. And this is a case where my center has been moved. I can see some H and K values up there that aren't 0. I do know this one's horizontal though. I see that 16. 16 is bigger than 9, so I'm looking at a horizontal one. I'll just say horizontal, and again, sometimes a little picture helps. Center to -2. A 4, B 3, square root of 9. C 16 minus 9, 7, so root 7. So remember, I need that A value and I need the C value to find my major vertices, my foci. I wasn't asked for those values as part of the problem, but I was asked for the major vertices and the foci, so it's good to go ahead and just list those 3 out, and I've got them. So we're going to move 4 units for the major vertices. Anyway, we're going to move 4 units. Left of the center would be -2, -2. Right of the center would be 6, -2. Foci, I'm going to move root 7 units left of the center. So -2 minus root 7. Excuse me. 2 minus root 7, -2. And 2 plus root 7, -2. I'm going to move root 7 units to the right of that x value of 2. Again, I could write those combined with the plus minus. If I don't like the radical, I can go get a decimal for root 7 and use a decimal value for my point. That would also be fine. 10 is not in standard form. So one of the things that I want to do is divide everything by that 576, because that's going to put it in standard form. Now it's not quite there. I wanted to show the division. I've got 576 underneath each piece. So when this reduces, I would have x plus 2 squared over 16 plus y minus 2 squared over 36 is 1. And let me just check my division there, make sure I'm right. Yeah. All right. So I've got my 2 values there. So I've got I know it's going to be vertical. I See that larger number under the y. I know my center then will be -2, 2. A, 6, B, 4, C, √20. This radical reduces. We could go 2 √5. I could also go to a decimal. Good with any of them. Okay. Major vertices. We're going 6 units. And again, it's a vertical one, so I'm going 6 up, -2, 8. 6 down, -2, -4. Foci, -2, 2 plus √20, -2, 2 minus √20. Again, going up √20, down √20 for those values. The next couple of questions, 11 and 12, are asking me for the equation of an ellipse. So for my equation, I need to know, again, what the orientation would be. Is it a vertical? Is it a horizontal? I need to know where the a value is going to be. Is it going to be under the y or under the x? So similar to what I did for the parabola, as far as finding an equation, a quick plot can help. So on 11, it says my center's at 0, 0. My focus is at -2, 0. My vertex is at 3, 0. And again, it's referring to a major vertex. And that's enough to tell me that this has got to be a horizontal ellipse, something like that. So I know it is x minus h squared over a squared. The a's got to be under the x, it's that horizontal look, plus y minus k squared over b squared is 1. All right, so h and k, 0, 0. So I've got x squared over plus y squared over 1. To get that out of my way, I just need my a and b value. B now. A, right there, center to vertex. A is 3. So I know that's 9, 3 squared. Center to focus. That's my C value of 2. So I don't have my B, but I have A and C. So what I know then is C squared is A squared minus B squared. So C squared's 4. A squared's 9. That means B squared would have to be 5. 9 minus 5 is 4. We'll follow the same process in 12. I'll plot what I'm given to kind of give me an orientation. So I've got a center at 0, 0 again. Focus at 0, 3. Vertex at 0, 7. 4, 5, 6, 7. So there's my vertex. So this has to be a vertical one. I look at something like this. Again, not a perfect sketch, but kind of giving me an idea. I'm looking at a vertical one. All right. H and K, I know are 0, 0 again, so I'm just going to go ahead and write this one as x squared over b squared plus y squared over a squared is 1. So again, the a under the y this time because it's vertical. A is that bigger one. Right. I do the 0, 0. So once I get those a and b values, I'm done. A, vertex to center, a 7. So 49. Focus to center, C. C is 3. And I can go back to my C squared. A squared minus B squared. So 9 is 49 minus B squared. That's going to make that B squared of 40. All right, the application problem, 13. I've got a semi-elliptical bridge over a highway. Top of the arc's 35 feet above the ground, which is tells me that's the major axis, so that means that's the major vertice. What should the span of the bridge be? The length of the minor axis if the height is 25 feet from the center, 16 above the ground. All right, so orientation. I want my center to be at 0, 0. Again, I'm going for one of the easiest orientation I can get. I would rather have that center at 0, 0. It kind of takes out the HK idea. I don't need to worry about those guys versus putting the center somewhere else. So there's kind of a diagram here. Here's my center. And so my bridge, I'm not the best drawer, but looking something like that, where that's 35. I know that point up there is 35. All right, so right now, what I know, this would be x squared over b squared plus y squared over 35 squared is 1. And I know that a is 35. They told me that was the major axis. So that's going to be my major vertex. All right. Now, what else am I given? I'm given the height is 20. The height 25 feet from the center is 16. So some point over here, and again, I'm not worried about the scale. The x value is 25. 25 from the center. The height's got to be 16. So I now have the x and y value. All right. Since I have the x and y value, (25 squared over b squared, not equals, plus 16 squared over 35 squared equals 1. I have everything in there now except for b, but b is what I was asked for. I was asked for the span of the bridge. So I am asked for this length right here. I need to work this to solve it for b. 25 squared, I think that's 625. Yeah, 625. So I'm just going to move up here. 625 over b squared equals 1 minus 16 squared over 35 squared. Which is 0.791. You can leave fraction, go to decimal. I've got a lot of numbers I'm working with. A little easier for me to just go ahead and make that 0.791. Okay. So now if I multiply both sides by b squared, 625 would be 0.791 b squared. So b squared is 625 over 0.791, which means b is the square root of that fractional value. And so I got 790.139 before I take the square root. So if I square root that, I'm getting 28.1. So b is 28.1, and it'd be 28.1 feet. So this is where I need to be a little bit careful. It does ask me for the span. So I know that this x value right here is 28.1. That means this one's negative 28.1 because that's the distance from center to that minor vertex. So the total span would be 28.1 times 2, which would be 56.2 feet. That would be the span, because it did ask me for the span between the two. The b value is that 28.1. The total span would be double that. All right, the hyperbola, 14. We're asked to find an equation. Same idea as before when we had to find an equation of an ellipse or a parabola. I really need that orientation. So a quick plot can help me with that orientation. All right. So what does it give me? It gives me vertices at plus or minus 4, 0. So 1, 2, 3, 4, there's one. 1, 2, 3, 4, there's the other one. Foci at 7. That's an F. So that means it's horizontal. Horizontal, or we also say, I don't know how wide they are. I don't care. I'm just trying to get an orientation. I know it's horizontal, or we would say the transverse axis is the x-axis. Okay. So that means in my standard form, x is coming first. X minus h squared over a squared minus y minus k squared over b squared is 1. All right, I need the center. Well, the center is equidistant, so if the vertices are at plus or minus 4, 0, the center's got to be right here at 0, 0. So now I know it's x squared over something. Y squared over something's 1. Center to vertex, that's A. A is 4 units. So A squared is 16. Center to focus, that's C. C is 7 units. So what I know is on a hyperbola, C squared is A squared plus B squared. So C squared is 49. A squared is 16 plus B squared. And so 49 minus 16 would be 33. There's my B squared value, that 33. So on the hyperbola, the orientation is telling me what variable comes first. A was always first, not necessarily the biggest one like it was in the ellipse. All right, 15, 16 are asking me to find all the information about a given hyperbola. All right, so this one up here, 15. I know again it's a hyperbola because I see the minus, and I know it tells me in the instructions it's a hyperbola. That minus is key there. Right. This one has to be a horizontal one. Right. So this means the transverse axis is the x-axis, meaning it's parallel to the x-axis. I know it's horizontal or transverse axis, x-axis, because that x value is first, similar to what I had here. The center, 0, 0. I don't have any h or k up there to worry about, other than 0. A is 12, B is 6. There's my square roots, like I've done before. C, 144 plus 36 would be 180. So C would be root 180. I'm happy with root 180. I'm happy with a simplified radical there. I'm also happy with a decimal. Makes no difference. Same as what we've talked about before. Okay. All right. Vertices, foci, asymptotes. Vertices, 12 units away. And it must be left and right. So we're going to have plus or minus 12, 0. Again, if I'm a little bit more of a visual person, think about this. My center is a 0, 0. And since it was horizontal, that means it's looking like this guy. One opening left, one opening right. That's going to push my vertices out here at 12 and negative 12. So I'm looking something like that. Foci, root 180, or its decimal or simplified radical from the center. So root 180 comma 0, going left and right of center. Asymptotes. Y minus 0 equals plus or minus something. X minus 0. I don't really need the zeros. They're not going to change anything in this case, but I'm just throwing them in there. That's my h and k value. And now, since it is a transverse axis, is x-axis, the slope is b over a, which is 6/12. 6/12 is acceptable. 1/2 is acceptable because 6/12 would reduce. Could even put 0.5 there for that value. 16, next one. 16, same idea. Just the center moves away from 0, 0. Sometimes that can make it a little bit more of a fit for us. So on 16, I again know it's horizontal because x is first, so the transverse axis is the x-axis. It's the center that moved from that 0, 0. So the center would be -2, 3. Then I can work for my a, b, and c value. So a is 4, square root of 16. B is 5, square root of 25. And c, 16 plus 25 is 41, so root 41. Vertices, 4 units. Since it's horizontal, left and right of the center. Again, always feel free to go do a quick sketch and plot that point -2, 3 and count. Okay? If it's easier for you, if the picture helps. But if I go left 4 units, that would be at -6, 3. Right 4 units would be at 2, 3. Foci, -2 minus root 41, comma 3. Again, decimal's fine also. And -2 plus root 41, comma 3. And then my asymptotes, y minus 3 plus or minus something, x plus 2. I like to just always go get that down first like I did with the zeros over there. I'll come back, get my slope. It's horizontal, so that's still the b over the a. So 5/4 for the slope of those asymptotes. All right. 17 switches gears to matrices. So looking at 17, we're asked to find a 2x2, actually 17 and 18, a 2x2 determinant. Okay. 17. 1, -8, 3, 7. All right, so the determinants, we're going to go down this way, minus, coming back the other way. So I'd have 1 times 7 minus -8 times 3. So 7, that would actually be plus 24, 31. Down, minus, coming back. 18. See, 12, -7, -4, 3. So we're going to go down diagonally, 12 times 3, minus -7 times -4. So that's 36 minus 28 is 8. And then 19's telling me that the 2x2 determinant value is 8. So since that 2x2 determinant value is 8, I need to now solve for x. So kind of a little bit different take. 5, 9, let's see, -2x is 8. All right, so I'm told the determinant's 8. So I'm going to evaluate the determinant with an x in it. 5 times x minus 9 times -2. So I'm still going down, minus, coming back, but I know the answer is 8. That's giving me my equation. 5x plus 18 is 8. And now I've got an equation, not too bad to solve for there. I can subtract my 18 over. It gives me a -10. And then divide gives me x is, I can write, x is -2. 3x3s. 20 is a 3x3 determinant. More work, larger matrix, so it's going to be a little bit more work to find the determinant. So let's see, I've got -2, 5, 4, 3, -2, 1, 1, 6, -3. All right, so on a 3 by 3, step first was rewrite the first two columns. So -2, 3, 1, 5, -2, 6. And so we're going to go down, 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 minus every one coming back. So I'm going to start this -2. We're going to go plus, plus that value, plus that value, minus, minus, minus. So I'm going to have diagonally, starting at that -2. -2 times -2 times -3. Plus, now the 5 coming down, 5 times 1 times 1. Plus 4 times 3 times 6. And then minus each one coming back. So start on that right side at that 5, minus 5 times 3 times -3, minus -2, 1 and 6, moving diagonally, and minus 4, -2, and 1. 4, -2, and 1. And the rest of the way is just getting all of the different calculations. So let's see, that would be -12 plus 5 plus, looks like 72, minus, and this would be actually -45, so it'll be minus a -45, which becomes plus 45, minus a -12, which becomes plus 12, minus a -8, which becomes plus 8. And then rest of the way there, let's see. Looks like I've got 130, unless I've got a calculation mistake there. 21. Cramer's rule, so an application of using our determinants. So a 2 by 2, I say 2 by 2 because 2 equations, 2 unknowns, using Cramer's rule. All right, my equations up here. 2x minus 2y is 8. 2x plus 2y is 28. All right. Done. We need to first find our base determinant, D. That's going to be the x and the y column. So I've got a 2 by 2 piece there. So I'm going to have 2 times 2 minus -2 times 2, which would be, that would be 4 plus 4, 8. There's my determinant, my base determinant value. Then I need D subscript x. So D with respect to x, determinant with respect to x. This was where the answers, 8 and 28, replaced the x column. And the y column stayed the same. So now I would have 8 times 2 minus -2 times 28. That would be 72. Then D subscript y. D with respect to y means the answers, 8 and 28, are replacing the y column, and then the x column is back to that 2 and 2. So we've got 2 times 28 minus 8 times 2. that should be 40. Now I've got the values that I need to solve this using Cramer's rule. So Cramer's rule. X was my d subscript x over d. Y was my d with respect to y over d. And I have my numerical values there I can substitute in. So that would be 72 over 8. So x is 9. And then 40 over 8. So x is 5.